Is software composition analysis the answer to finally get us out of having to do tedious, annoying static code analysis for security? Is it the silver bullet we've all been waiting for? Let's take a look at that. So lately I've been hearing a lot about software composition analysis. I see things in articles, in blogs, various industry analyst reports, etc. And it's a pretty interesting topic, right? SCA, or software composition analysis, means that when I build a piece of modern software, there's a lot of stuff in there that isn't my own necessarily. And that stuff might be an API hosted in the cloud from a third-party service. It might be some open source library I'm using. It might be a commercial library I'm using. But there really are a bunch of components inside of our software today. And a lot of them are based on open source. We get tons and tons of pieces of functionality from open source today, some of it in extremely high use. We saw that with Heartbleed and OpenSSL, that most people just incorporated OpenSSL into their systems and applications rather than create their own encryption layer. So the idea of software composition analysis is, first, we try to understand what open source components or what other components are we using, and then make sure that we're not using ones that are bad. And this is pretty intriguing, right? So if I take Heartbleed as an example again, if there is a known version of a known open source component that lots of people use, and it's broken and it gets fixed, I should make sure that I go and get that fix. So the trick with an SCA tool is that it scans your software and looks for recognizable stuff, right? It's kind of like a bill of materials, sort of, like a lightweight bill of materials. It sweeps through your code, for example, and says, oh, look, I found OpenSSL, I found Access, I found Ajax, I found whatever I found. And I recognize that this one's version 1.2.3 and that one's version 4.5.6. Then you look it up against a system of known information. And things like the National Vulnerability Database and other similar systems where people report known software problems, CVEs and such. And we simply look and say, does version 4.5.6 of the curmudgeon widget have any known reported security problems against it? And if so, we let the user know. If not, we tell them it's okay. So it's really cool because we know that the amount of deployed software in the world that's using broken components where a fix is available even for free is shockingly huge, absolutely shockingly huge. So why not update these things and fix them? Now that sounded like a really stupid easy answer. Why not do it? There are legitimate reasons not to do it, and if you have other controls in place, thank you, Mr. Sparklet's truck. If you have other controls in place, it might be okay to let a certain vulnerability exist in your application because perhaps the ramifications of the new version might be really, really bad for you. Components changing is going to change your software potentially and might cause new bugs. So it's not as easy as maybe it sounds, but it is certainly worth doing, especially if you start to keep yourself up to date. If you get into the process and you do it early, not the night before you deploy or the week before you deploy, you decide to look for things. If it becomes part of your daily effort, then it's not that big a deal. It will be on day one if you've never done it before. But I wanted to talk about this because what's happening is that, I don't know if this is just marketing departments for companies that build SCA, or if this is just human nature that we focus on the latest thing that we learned. But there seems to be, in the security arena, this movement away from static code analysis for security and toward SCA. And I have seen some marketing departments actually like promoting this concept that once we get SCA working, we won't need to do static anymore. So first of all, there are no silver bullets in security, not in physical security, not in cybersecurity, not in software security. We have to get over that idea. The only way to get secure software is to build secure software, to be mature, to do the right thing, to take the effort, to think about the problems and build software that is much more difficult to hack and put around it a series of controls that helps enforce that. you can wait for a silver bullet. It's not coming. It's just not coming. As we create little silver bullets, maybe they're bronze bullets, they help us, but complexity of software is increasing, the attack surface is increasing, so the bronze bullets are only helping us keep pace probably. But I want to help you understand how SCA is different than static code analysis, right? SCA sounds like static code analysis, right? And it's software composition analysis, but how is one different from the other? And here's the basics, right? Software composition analysis is based on components, may or may not be open source, but most of the solutions out there right now seem to be open source oriented. And essentially, they're not looking for vulnerabilities. What they're doing is checking a database somewhere of known vulnerabilities and letting you know that something that was already found before exists. This is learning from someone else's knowledge. Again, that's a great idea. You don't find new vulnerabilities with software composition analysis. You only find known issues. That is its nature. Static code analysis, on the other hand, is scanning code where you don't know if there's a problem, and if it finds something, it's new to you. So these two tools perform different functions that are complementary to each other. It's very important to look for problems in your code, and it's certainly important if you're reusing someone else's code to make sure that you're up to date and have fixed any problems that they have found. So both important, but there's no way that looking for a set of known problems will replace the issue of looking for problems on your own. It might well be that you update to the latest version of curmudgeon widget 789 and there are no CVEs, no NVDs, no known issues, but it still has security weaknesses and vulnerabilities in it. And if you run static code analysis, you will find it out. So just wanted to make that clear. These are two things you should be doing. Unless you only write 100% of your own software, you absolutely should be doing software composition analysis. In fact, there's a free tool from OWASP, the OWASP dependency checker. I'll put a link down below. Go run it. Why not, right? Go run it, start looking at what it's telling you. But on the other hand, you should be scanning all the code you write for things like the OWASP Top 10 or the CWE Top 25 or the CERT Secure Coding Standard or others. You definitely want to check the code you wrote because it won't show up in software composition analysis. And you can't say, I'm only going to check other people's code but not my own. That's just crazy. When I say it that way, you know it's crazy. So you should be doing both, and if you're a really good person, you should be doing that also on the open source software that you're including in your system. If you're using curmudgeon widget 789 and you have it in code form and you're just putting it in as part of your build, you should run OWASP Top 10 on it. And if you find something new, you should report it or fix it because it's open source and contribute the fix back. If everyone was doing this, we would have much better software security. Again, I look at OpenSSL where literally thousands and thousands of organizations were using OpenSSL, are using OpenSSL, didn't bother to run static code analysis, didn't find the obvious problems that are in there and didn't fix them. They just used it. It's a free lunch. So as part of this, I just want you to recognize static code analysis finds new problems in your code. It's important. Software composition analysis finds existing problems that someone else is aware of and tells you about them if they're in your code. And these are both important, but if you want to be a really good member of the software community and you're using open source, give back. And give back doesn't have to mean creating a brand new code project. It might merely mean that if you're using a particular library over and over and over, that you take the time to scan it for security, fix problems, and contribute those fixes back, which makes the world a better place. So let me know what you think. If you're still not clear about why these are different, or if you disagree, let me know. Thumbs up if you like the video, subscribe to get more, and as always, have a great day.